Hi, so I've been getting a few requests about how I set these controllers up and how I wire them up, and I'm going to do a video here just to run you through what the ingredients are and how I use them. So here we go. You can probably see here I've got probably the main component is this board. This is the one I use. You could use all sorts, but I find these very easy to use and extremely durable. I've shorted them out and all sorts, and they seem to take a lot of abuse. Just unplug them, plug them back in again, and away you go. So I can't really grumble on them. Now I'm showing you on here. You get basically 8 analog inputs, so potentiometers, Hall effect, whatever you want, basically on an axis, and then you also get these what's called columns and rows here. And the thing with this is you can set it up and use apparently about 36 buttons if you want, but then you've got to set up a matrix. But as long as you don't use any more than 12, which basically means 6 and 6, so that's 12 pins, you can just use the direct connections to each pin to ground without having to use a matrix and diodes and so on, etc. But if you do go above the 12 button kind of limit, you will need to then use a matrix. But anyway, that's a whole different ball game. But instructions on the site where you buy this are very good, and they'll show you how to wire all the bits and pieces and how the whole thing works. So that's why I do like these. So it's yeah, Leo Bodnar BU0836A. Very simple boards. And now I actually get the ones without the pins on. You can get a different version of this for a little bit more money, where you've got pins sticking out here which allow you to insert, or should I say plug in connectors, and it allows you to sort of easily connect and disconnect stuff and test. So if you're doing it for the first time, probably that's what I did. I had the pins and so on, etc. And it made life a lot easier for prototyping. But I've since found, having used one of the ones with the pins in for quite a while, that it's I guess vibrations and whatnot and oxidization started to cause resistance on the pins, on the connectors. So that unfortunately will then affect stuff like, you know, steering potentially. If it's on the steering axis, it's going to affect your center, and it's going to be off constantly. And then I found I had to keep reconnecting these, and then eventually I just soldered them on direct, and problem was solved. So what I do now is pay a little less for a board, and you can see here I wire directly to the board and solder directly to the pins. No issue with durability. Then the axis will not wander over time. So that's the board. It doesn't even come with a USB lead, so I actually have to solder this on, but that's basically straightforward. Just get a cheap USB lead, or actually had some hanging around, and cut the end off it, solder the wires to there. It's all pretty. It's actually a little chart there, tells you what colour wire does what, so it's pretty easy. And this stuff's all over the internet if you want to find out what's going on. I've just put a little bit of glue there as well, just to hold this. Actually, it's a little bit loose, but anyway, I'll sort that later. So I've actually already rigged up a sensor here and a button just to show you how they work. Now you can use potentiometers with this. It doesn't matter. If you look again on the site, it tells you all the bits and pieces you can use, or you can use, as I do, because I don't really like the potentiometers because they wear out. You've probably heard of stick drift. That's caused by potentiometers that will wear out, especially if you play a game such as MX Bikes. The repetition is just such that it's going to wear out. The carbon on those scrapers is just, yeah, it's just never going to last. And the odd thing is it's known, and yet they don't seem to like do anything about it. So anyway, these chips, ICs, what I call them, they're not ICs, these sensors effectively replicate the pots, but without the contact, so they don't wear out. And I have never had one of these fail. I've broken a few by sort of mistreating them, but I've never had one actually fail, because there's not really a lot to go wrong. It's a solid chunk of plastic and bits of wire, and away you go. There's obviously the detector in there, and that's it. So it's wired the same as any pot, and I can probably show you here if you can see it. There's the pin out, so basically ground in the center, and if you hold them the right way up, I'll show you here now, they have you'll see the two, you see the lines on there. I don't know if you can see the screen properly, but anyway, there's 2 lines on there which represent the 2 little chamfers which exist sort of there and there. So therefore we're looking at that way around. So essentially the middle pin is ground, 5 volts on this side, and then this is your output, which corresponds to this board. So we've got your 5 volts, inputs, and the ground. So pretty straightforward for that. 3 wires, 3 pins, get them right. And again, the beauty of this board is if you get it wrong, which I've done numerous times, it just doesn't work, and then you realise your mistake. You know, I've shorted them out and all sorts of things. I've done some really terrible things to this board, but it just recovers. So really am quite impressed with these boards. So that's that sensor wired up, and also I've wired up one button, which is just a case of I steal a ground from here. So this is one of the ground pins, or the ground line, and then I just wire it over to pin 1, and then that's a button which is just basically shorting out those two when I press it. Simple as that. And obviously you can use this ground, again, have 12 buttons, same as this, do the same thing, and I'll show you those in action in a second. So there's the board, there's the sensor, there's a button, we've got our leads plugged in. So the only other thing you need for these sensors is magnets, various different types of magnets. So I've got 10 by 10 one here, I've got 3 5x5 set up here, I've got some other ones here, we've got some 5x5 cubes, and then these are the little magnets that are actually in this one. And I stack them side by side to give myself a bit of range and a bit of extra movement. Obviously you could use these 10s instead. These are a bit more expensive though. So what I'm going to do is just show you how I test these. So basically I bring up, it's called, basically I type in USB there and you get USB, set up USB game controllers. And you'll see there's nothing detected there at the moment, but I'm going to plug this in. Get the right way up. And there we go. So we've got our BU0836A interface that's detected that. It says it's okay, so happy days. And that's basically it. So what I'm going to do now is switch over to show you. I'm going to get this screen up, so hang on, let me just go to properties on this. So when I test these, I'll bring this interface up, go to properties, into settings, and then calibrate. Now you can see there it's just said, you know, press next, and then it wants you to press a button. You don't have to do that, but I'm going to here. So here's my button. I'm going to press that. There we go. That's reacted. The other thing I like to do is to get some numbers. Is hit this display raw data button. I'm not sure if you can see all this there, but this gives you the actual numbers it's outputting. And as you can see there, at the moment it's not connected to anything, so it's sort of sitting neutral, which is 2040 odd. But there is some magnetic field around here, so it's picking stuff up. They are really, really sensitive. But also you get them near a magnet and things will change. So what I'll do is rig up so you can see this screen better, and then we'll go through what occurs when you start waving these around magnets. Back in a sec. Okay, so back again. I've got this screen sort of zoomed in. So what I'll do now is with our little sensor here, which I've just, this is a little pivot, little axis, which I've just glued on the top of here very crudely, but it does the trick. So let's start with this say. So we've got a magnet here, and basically I'll slot that into there, spin it around, and there you go. We've got ourselves an axis. So pretty straightforward in that sense. All you're doing is waving this in front of this magnet. Now it's pretty simple in that sense, but it gets a little bit more complicated when you've got to figure out the magnet. So if I don't get the magnet orientation correct, it's not going to work correctly. It's not going to work. It's not going to be happy. It's going to give us something, but not what we need. So this magnet, and all magnets obviously have magnetic fields that they surround, or that surrounds them, and you need to have a look and see the magnetic field to find out what you're dealing with here. So you can see on this, I've got a bit of paper here, which effectively is like iron filings, but without the mess, so I can see the fields. Now you'll see on this 10mm one, so there's the magnet there, and sliding down, so you've got the center line smack dab in the middle, and then either side of that you can see the two north-south lobes. Now it doesn't matter which is which, they do represent 0 and sort of max on the slider, but it doesn't really matter which way around you get it, because any game you can reverse them, and any game can reverse them as well. So as long as you get the movement in there, you'll be fine. It's not that fussy. So this is what you need to wave the magnet across. Now the problem with this is, if I can actually super glue that in there, here we go. If I get another magnet out, so I've got a couple of magnets here. Now these, I know the orientation of the north and south, and you need to know that with the magnet when you're using it. So for instance, if I get this magnet here and put it in front of this, you'll see, let's just trigger off that. You'll see we've got a smaller magnetic field than we had on that 10mm one, but this can also be useful for things that don't have a lot of rotation. So you can see the little magnetic field there. You've got the north and south lobe on either side, and that's how you must present it to the face. So basically we need the sensor to be going over this side of it. Now the problem occurs if you don't get the orientation right. So say we get it like that, so the thing's face on, we get a field, but you'll see it's not got the two lobes on it. This is just one pole we're looking at here. So what I can show you kind of is if you look at the numbers, we put this in the center there, you'll see we're getting our rotation there, no problem. So we're getting 4,000, which is basically the max. I think it's 4,039 is max, so you're not getting anywhere near 4,000 if you're doing well. And if you get that to go to 0 or anywhere near that, you're doing well. That's 4,000 steps we've got in between there. So you can see that moving in and out. So if I now flip this, you'll see that it does kind of nothing. It's not happy on that at all. It's basically only seeing one pole, and as far as it's concerned, it's just sat in the north or south pole. I don't know which one it is. It's easy to find out, just get yourself a compass, but it's not really relevant. So we could spin that around again. This is another pole here, and you can see instead it's going to go to the max and stay there. So we've got max this side, min that side, but you need to show it a bit of both, which is side on. So in this thing, we can get the movement. There we go. We've got all the steps in between. It's very, very sensitive. So. But this is basically how I've set all the sensors up. Now what I do is I actually use these small magnets so that I can stack them up like this in a 3D printed piece of plastic, and then it allows me to get my nearly getting 4,000 there. I haven't got quite lined up right enough, but that's plenty. That's good enough. And the beauty with these is you can stack them up. So I can make this, 4 or 5. I've actually got in my steering one. I think I've actually got 5 or 6 magnets in there, because the steering rotation is actually potentially higher than any other axis I've got. The steering, I believe, is on mine is 90 degrees. So I need something that's going to be able to handle that, the 90 as it were. So yeah, it's going to be sort of like that the whole time. So obviously this one would not do that. It goes out of range long before that. This is more for something like a brake lever, or perhaps your clutch lever or something like that, where there's not a lot of motion. So if you imagine you let's say we're keeping the sensor still and moving the magnets around, you can imagine a foot pedal out sticking out here, and someone obviously pushes on it. There you go. There's your movement. So you'd extend this out here, and put a lever on it and make it a metal, or attach this to metal or something like that. And also, just to say, if at all possible, move the magnets, which are not connected to anything, not the sensor, which has obviously got wires on it. So if you move this, you've got a wire strain issue going on. So if you can keep this dead still and just strap it solidly to the frame, whatever, and then move the magnets, that's by far the best way, because you just can't really go wrong then. And there will be no fatigue on the wires. So you can see they're moving in here. Now, the other trouble is you've got to constrain, obviously when you've got, say, a steering axis, you've got limits on either side. Now you've got to make sure they are within the bounds of the magnet. So if we just pull that out there, look, go back to this. So you can see there we've got our, so you can see this, so that's the effectively the edge of the magnet there. So when I pull it down, you can see the two lobes there, and then effectively the max is kind of there. So we've got that amount of distance, which you could measure if you wanted. So you need to make sure your axis isn't going to go outside those bounds. If you do, you'll see what occurs is, so let's just sit that in the middle roughly. So we get, say, 2,000 there roughly in the middle. So then if I go to the edge, so we've gone up to 4,000, well, this is going to 3,800 max. So then if I go any further, it starts coming down. So you've now blown through the magnetic poles, and you're going to get a negative. So it's going to go down rather than going up. So you see it's going from low there through the 2,000s up through to 3,000, 3,800 roughly, and then it starts coming down if I go any past that. So this would not be any good for anything that's moving that much, if you see what I mean, because I'm getting, you can see it's bouncing in. So this particular one, I'd have to constrain it to go no further than there, or roughly there, about there. You can see where it starts coming up, and then the maximum would be about there. So that for this thing would be our travel. Now the other factor is you haven't got to get too hung up on this. You can change the distance it is away from the pivot point. Obviously this isn't very far, but if you needed less movement, you can move this closer, and effectively then you're going to get less of an arc, and if you move it further away, you're going to get more of an arc. So you should be able to adjust this so you get the perfect arc on your particular setup for whatever you're doing. and I've found that to be very useful. And you can just, as I say, expand these or shrink these, and these are really cheap, these things, they're not much at all. I buy about sort of 20 of these at a time, and that does a couple of controllers. So yeah, that's basically it, and that's kind of all the tools. Again, we need a button here. So let's see, I haven't actually done this yet, so one thing you've got to be careful of, if you calibrate, you can only calibrate once. So now I've done this with another one and got some different results, it's going to expect that. So what we need to do is just go back here and go in again. So I'm going to calibrate only with this one. So we're going to go that way and then that way, and that's it. I'm going to leave it there. So this thing is now, should be happy. So then if I just go next and finish, we can then actually see, so you can see that's moving there. There's effectively our steering, which is moving around. And technically we could go in game and you know, assign this to steering or something like that. It'd be terrible, but you know, it would work, it would function. And also then we've got ourselves a button. So we watch button 1 there. There we go. That's button 1 is happily doing its thing. And that's basically it. You just rinse and repeat as many times as you need sensors for, or buttons for, and away you go. And this thing is plug and play. And by the way, one important thing with this is that it maintains its product ID. So if you plug it into a system and then unplug it, plug it in again, it will be the same controller. Some cheaper boards, or certain boards, I don't know exactly which ones to be honest, but there's so many out there you can do this with, you really are spoiled for choice. But some of them I know are not doing that, and they actually generate a code kind of, I think I'm not sure about this, but I think they generate a code every time they're started up, which means that every time Windows sees the controller again, it will think it's a new controller. So what will happen is you'll set everything up in the game or wherever it may be, calibrate it, then when you plug it in again, it says, well, new controller, please calibrate again. Whereas with this, it will recognize it and the calibrations will hold. So that's one thing you've got to make sure with that, because it can be very frustrating if you've got to set up every time. But this thing seems to cover all bases pretty much. And yeah, as I say, you can get all sorts of different types of magnets. There are loads and loads to choose from. I find the smaller ones obviously are cheaper, and you can then use them in a stacked fashion. But again, you've got to make sure you get your orientation correct. Make sure you get your north-south in the right place. Something you've got to bear in mind. And that's pretty much the key to it, I think. The rest of it's obviously rigging it up onto your controller in some way, shape or form. I've got a 3D printer now, which makes life a hell of a lot easier. But when I first did this, I didn't. I had to use basically Bic pens and various bits and pieces just to hold the magnets and then spin them around a magnet or move them around a magnet. But with a glue gun and that, it worked a treat. Hideous mess, but it functioned, it worked, and was pretty much the first controller, and it lasted for a long time. So yeah, I'm pretty happy with this, and fingers crossed that'll help some others get into it and get their controllers wired up and running. We shall see.